In this paper, the aim was to design a compliant mechanism that would grip an object and retract it in one single mechanism with one actuator. The process used was a kinematic substitution method. And so the first step was a rigid body model of the design. Here we can see a design of the rigid body model with roller bearings and springs indicated in the design and the input actuator. The main spring to note is this spring on the decoupling beam, which allows for decoupling of the X and Y travel. The mechanism moves as so. Input from the actuator pushes on the two internal surfaces, which causes the jaws to close. Here we can see the retraction stage and note the compression of the decoupling beam. Using the kinematic substitution method, a compliant mechanism was developed. Here we can see the X travel parallelogram mechanisms, the Y travel parallelogram mechanisms, the input bar and its parallelogram mechanisms. We have the decoupling beam and the X and Y travel stopping features. The model was split in half down the line of symmetry and imported into ANSYS. The appropriate supports, contacts and joint conditions were added. The mesh underwent a process of refinement, resulting in a suitable mesh giving good accuracy for this model. The model shown here has gone through the process of optimization, and it can be seen that the beams of the X displacement and Y displacement have been optimized. It can also be seen that the parallelogram mechanism of the input bar has also been optimized for length, and also the diagonal beam has gone through the process of optimization. Here we're looking at a deformed model, and if we take a look at an animation of this deformation, we can see the mechanism in operation. We can see the X displacement and gripping and the retraction stage. It's worth noting the large deformation of the decoupling beam.